Today we're going to demonstrate making your own custom class or custom object. It's far easier than people think. We're going to continue a previous example, which was to enter grocery items and their prices. Today we're going to do a grocery list using a class. You'll notice that the class isn't the list, but the class is the item on the list. That way we can make an array of grocery items that will be the list. To do this, we make two classes. One is going to be the grocery item class. Remember, this does not have a main because we're not going to execute this one, so this is not a program. The other is the program that tests the data. Programs that test the data, or programs or applications, always have a main. So we're going to have that program have the main. First, we'll make the grocery item class. All you do is choose the icon that shows the piece of paper with the plus sign above it in the upper left-hand corner if you're using NetBeans. That will get you to a dialog that allows you to choose the type of class. You choose Java and New Class, Next, and then name your class Grocery Item. Then NetBeans will have filled in some of the basics of the class. Here's the class, and as you can see, it's quite simple. It has only two member variables, name and price. It also has two constructors. The two methods that are called constructors have the exact same name as the class, including the capitalization. That's important. Constructors are an important part of the class, and they're necessary in every class because they tell you how to construct the item. Now, if you look at the constructors, you'll see that they have the exact same name as each other. The only difference is the number of arguments that you pass and the type of arguments that you pass, which is called the method signature. These must be different between constructor methods. To use this class, you're going to make an object of the class. Remember, the class is like a template, cookie cutter, blueprint. It tells you how to make an object. It doesn't use the object. So in the program that uses the object, we're going to declare it. So similarly to declaring a string, you're going to declare an object of the type grocery item. It's going to involve the word new, and now you're going to understand what you really are doing. In that second part of the statement, it says grocery item, and it uses the constructor. So you are using the constructor methods that we just wrote. Now, when you use this class, you're going to now be able to use something called the dot notation. To get at a member of the class or the variable of the class, you can say item.name. And that's a dot notation you've seen before. Here's the test program for the grocery list class. The first thing you want to do is you want to make sure that you exercise both constructors. So the first constructor we're exercising is the one that has the two parameters passed to it. We pass apple to it and $2.33 for the price of apple. Then we go on and we use the second constructor to create a second grocery item. Grocery items are 1 and grocery item 2. The second one, we separately set the actual item, which is banana, and we separately set the price. Now we have two simple print line statements which allow you to print out the actual cost of the item and prove that these items were created. A lot of times students don't know what they should properly test. Whenever they create an object, they should test everything within that object. In this case, it's two constructors, so you definitely want to test each constructor. In addition to that, if you had other methods, which you might have, and you will have in the next lesson, you do want to make sure that you test each of those methods. In the next lesson, we talk about encapsulation. So far, we've only made members of a class be public, but that's really not a good idea. It's much better if you can make sure that most of the members are private and have methods that check the data as it comes in to make sure that it's valid data. That's called encapsulation of data, and that's what we'll talk about next time. Then we're also going to talk about UML, which is the Universal Modeling Language. I'm going to show you just the very beginning of that. And then later we'll have lessons on inheritance, polymorphism, and interfaces.